You know that Rubik's Cube? A lot of us just see it as a toy, right? Maybe a super frustrating one. But what if I told you it's actually one of the most elegant mathematical puzzles ever made? And that deep inside it, there's a secret number, a single number that took the smartest people on the planet decades to figure out.
Okay, so let's just jump right in with the big question. Picture the most messed up, completely scrambled cube you can imagine. The absolute worst case scenario. How many moves, minimum, would it take to solve it? Take a guess? 50? 100? What do you think?
The answer, and this is going to blow your mind, is just 20. That's it, 20. No matter how you scramble it, a solution is always 20 moves away or less. This incredible number, it has a name. They call it God's number.
But finding that number, oh man, it was anything but easy. We're talking about a 30-year quest. It was like a huge mathematical detective story that stretched the limits of what we could do with algebra and computers. In the end, it took 1 billion hours of computing time to finally prove it. So, how on earth did they do it?
All right, first things first. We need to get really clear on what God's number actually is, because it's not some random average or a good guess. It's a fundamental property of the cube, kind of like its DNA.
So here's the key idea. God's number isn't about most scrambles. It's about the single hardest one, the absolute worst of the worst. Imagine a giant map of every single possible scramble. The solved cube is at the center, right? Well, God's number is the distance to the farthest possible point on that entire map.
Okay, now here's a really important detail. The rules of how you count the moves, they matter a lot. That magic number, 20, comes from something called the half-turn metric. That just means any turn of a face, whether it's 90 degrees or a 180-degree spin, counts as one move. But look, if you change the rules, say a 180-degree turn is 2 moves, then God's number actually jumps up to 26. For this explainer, though, we're sticking to the standard. 1 turn is 1 move. So, 20 it is.
So, you might be thinking, 20, that's a simple number. Why was it so hard to find? Well, the answer is the sheer scale of the problem. It is honestly, it's just mind-boggling.
That number you're looking at, that is 43 quintillion. That's how many different ways there are to scramble a Rubik's Cube. To put that in perspective, if you had a cube for every single one of those states, you could cover the entire surface of the Earth over 275 times. And to prove God's number, you have to account for every single one. So how do you even get a number that big? Well, it's all about combinations. You've got 8 corners that can be in different spots and twisted in different ways, and 12 edge pieces that can do the same. And this is the really cool part. The way the cube is built puts some strict rules on it. These rules are so strict that for every 12 ways you could theoretically put the pieces together, only one of them is actually possible to get to just by turning the faces. The other 11? They're like ghost cubes. You could pop the pieces out and build one, but you could never, ever solve it. Okay, so you have this universe of 43 quintillion states. How do you even begin to make sense of it? You can't just count them. You need a better tool, a kind of secret language to describe how the cube works. And for mathematicians, that language is called group theory.
And it turns out the cube follows 4 really simple, elegant rules. First, closure. This just means any move you make still leaves you with a valid cube. You can't accidentally turn it into, I don't know, a toaster. Second, associativity. Doesn't matter how you group your moves, the end result is the same. Third, there's an identity element. That's just the solve cube, our starting point. And finally, the most important one, inverse. Every move, every sequence of moves can be undone. That's the mathematical guarantee that every scrambled cube is solvable.
But here's the one property that makes the cube a puzzle. It's non-commutative. That's a fancy way of saying the order of the moves matters a lot. A right turn and then an upturn is totally different from an upturn and then a right turn. And that's why it's so tricky. You can't just do moves in any old order. You need precise sequences, algorithms, to get things back where they belong. So, the mathematicians had their language, group theory. And with that, the great hunt for God's number was on, a quest that would last for decades.
Way back in 1980, a mathematician basically said, I bet it's in the low 20s. They had a hunch. Then in 1995, they got a huge piece of the puzzle. They found a specific scramble that they could prove needed at least 20 moves. So that set the floor. The answer couldn't be 19. But the ceiling was still unknown. Was there some beast of a scramble out there that needed 21 moves? Or 22?
It took another 15 years to finally prove the ceiling, to prove that no scramble needs more than 20 moves. That closed the gap. The answer was officially 20.
So how did they do it? How did they finally pin it down and prove it? How do you conquer a problem with 43 quintillion parts? Well, it wasn't just one thing. It was a brilliant mix of pure mathematical cleverness and just raw, brute force computing power.
Yeah, checking every single scramble one by one was completely off the table. So they had to get smart. The genius idea was to stop thinking about individual scrambles and start thinking about groups of them. Using that group theory we talked about, they managed to bundle all 43 quintillion states into about 2 billion manageable sets. Then they used symmetry. I mean, if you can solve a scramble, you can also solve its mirror image, right? That trick cut the problem down even more. And for what was left, well, that's when Google stepped in, donated a ton of computer time, and they just crunched through the remaining sets, proving that every single one of them was solvable in 20 moves or fewer.
So there we have it. The number is 20, the perfect, optimal, most efficient solution imaginable. But what does that actually mean for us, for a person sitting there with a scrambled cube in their hands?
And here's the beautiful final twist. God's algorithm. It's perfect, but it's also perfectly useless for a human. To use it, you need a supercomputer for a brain that can see that entire map of 43 quintillion states all at once. The methods that real people, even the fastest speed cubers, use are way less efficient. They might take 50 or 60 moves, but they work for us because they break the problem down into small, logical steps, into layers and patterns that our minds can actually grasp and memorize.
And maybe the most surprising thing of all is this, right here. Those super hard scrambles, the ones that need exactly 20 moves, they are ridiculously rare, like 1 in 90 times billion rare. What that tells us is that the cube's map isn't some sprawling thing with distant, hard-to-reach places. It's actually an incredibly connected, tightly knit web. Almost every single state is just 17 or 18 moves away from being solved.
So in the end, the Rubik's Cube teaches us something pretty amazing. You can have a system that looks impossibly complex on the surface. 43 quintillion states. But underneath it all, there's a simple, beautiful, and surprisingly small rule. And it really makes you wonder, right? What other complex, chaotic things in our world? I don't know. The stock market, the weather, even our own biology. What if they're also hiding their own God's number, just waiting for us to figure it out?